Sitting in my back right now. Yeah. Yeah, I needed two, because I thought he said it was 2 today, but I guess I'm just going crazy. Yeah, you saw the get the last class, so I need to like take it down.
Morning, guys. We do have bus evacuation sometime this morning, so I'm guessing it's probably going to be here in a few minutes. But we'll probably either be the first group since we're on the third floor or the last group. So anyway, somehow, I don't know how it keeps happening, but they just keep on taking away and doing stuff on A days. So I'm trying to not keep putting you guys at a disadvantage, but that's what keeps happening. So we got a couple things we need to do today. So to move you along quickly here, number 42 is over something called candidates test and extreme value theorem. So my other classes took notes on that last week, and you guys just didn't have as much class time, so that's the part that we are behind on. I did last time ask you to finish up that number 41 and check your answers and all that stuff, but that one was also disjointed, so you guys know 99% of the time I would have asked you to turn that in, but just because of how, the day that I taught that and the day you guys worked on that after a test and all that kind of stuff, I wanted to give you a chance to ask some questions from that before you turned it in. So I will take up 41, but it won't be till next class. And then finally, there's a couple of practice questions from assignment 41 that'll end up in the book assignment. It's like 7 questions, but one question has a couple parts to it. So anyway, we got a handful of small things that we need to look at and work through. So first thing I want to do is start you off on assignment 42. So I'm going to go through the notes, talk about how this is similar and or different than what we did in 41. And then that way, if you have questions on 41, you can ask, but if you don't have questions on 41, you can continue yourself on 42. Okay, so in 41, without pulling it up, basically there's this idea of critical numbers that came up, which are, you need to know what they are, why they're important, and how to find them. Critical numbers are when the first derivative is 0 or undefined. They are the only places you might have relative extrema, and I don't remember the other question, but that's kind of the important parts of that. Whereas this one is not about relative extrema, it's about absolute extrema. So the very biggest y value and the very smallest y value. So in Algebra 2, you might have had your teacher call it absolute max, absolute min, or absolute extrema. Extrema is just a vague term for mins and maxes. Or they might have said extreme extrema, or even global. All of those really mean the same thing. So hopefully your Algebra 2 teacher used several of those. But again, last time we talked about critical numbers and how they can help you, the first derivative test, they help you find relative extrema. Now we're trying to find absolute extrema. So with this example over here, I'd like us to make up a quick little graph, and if you would, try to make yours look as close to mine as possible. So let's have an x value of a, and then it does some stuff, and then let's call this xb, this is xc, xd, and over here, oops, I'm sorry, I got to change it up on you. Sorry, I'm trying to get an example of, I'm sorry, my graph still doesn't work. Let me try again. I got to get an example that gets both things. Okay, so this, okay, that'll work. Sorry. Trying to give you an example why we need both the things that I'm about to tell you that we need. Okay, so from this made up example, the absolute min is right here because it's the very smallest y value. Absolute min. And then up here, here's the absolute max. So the absolute min or max there's only two types of x values that this could occur at. It could occur at like this one, which is an endpoint. So your absolute min or max could start off at the endpoint or end at the endpoint. It could have been x equals a or x equals e. Or it could happen at critical numbers, which again, I'm just going to keep saying how to find critical numbers every time they come up so that it's ingrained in your brain. And the first derivative is 0 or undefined. Now the connection to this for the stuff that we talked about on last week was critical numbers don't guarantee that we get relative maxes and mins, but all maxes and mins occur at critical numbers. So right here, anywhere where the derivative was 0 or undefined could have been an absolute max or an absolute min. So I need you to see from this made up graph here that a relative max ended up being the absolute max and an endpoint ended up being the absolute min. To find the absolute maxes and mins, you have to test the endpoints and all critical numbers. That's the only places that your graph is maxing or minning out. Okay, so this, I said this on the agenda, but it's not really written on here. And in fact, you don't even have to know this name, but basically what we're doing is the extreme value theorem, or EVT. So if you remember like the first or second week of school, we did something called IVT, intermediate value theorem. There's also extreme value theorem and mean value theorem that we'll get to in the next couple weeks. But extreme value theorem tries to make your life easier by reminding you how do you find the absolute extremes. So that's what we just talked about right up here. Extreme value theorem says if you want to find the absolute max and absolute min, test the endpoints, which in this question are -1/2 and 4. Those might be the extrema. And you have to test critical numbers. Now, you don't actually in your table have to say these are the endpoints, these are the critical numbers. But I will always write that, and I encourage you to write that because it just reminds you to always check those things. So extreme value theorem just says absolute max and min are going to occur at either these two or where the first derivative is 0 or undefined. So sometimes the derivative is done for us in this section. Sometimes we've got to take the derivative and solve. Honestly, a lot of this section is kind of combining your solving of equations in Algebra 2 with the derivatives we did in Unit 2. Now, as it stands, I couldn't tell you where the biggest and smallest is, but I can tell you it's going to either be at x equals -1/2, x equals 4, x equals 0, or x equals 3. These are the only possibilities. That's where it gets the name candidates test. Candidates test. The candidates are the things that are worth trying. If you want to add x equals 10 to your table, sure, but there's no chance of it being an extrema, so what's the point? Why would you do that to yourself? Now, think about this real quick. Where do these numbers come from? How do I find these?
From the function, not the derivative.
Exactly. Not the derivative. The derivative is great if you want to know whether it's going up or down. Positive derivative means positive slope is increasing. Negative derivative means negative slope means it's decreasing. I want to know the points. So I could plug in 0 into the function, and I know his y value. I could plug 3 into the function, and most of these are not too bad without a calculator, but I know I'm going to want to put the -1/2 in there anyway, so I'll just use my calculator.
Mr. Townsend,
Yes,
shouldn't the 3 be a 2?
it should be. Thank you. So, just because the solving was easy, don't fly by too quickly, like I did. And I probably did that on purpose anyway, so. Okay, so this is actually -3. When x is 4, it's 17. And I'm putting this in the calculator. You can just trust me. You don't need to do it too. And this is -1/2. Okay. But now, so what? I know when x is 4, y is 17. When x is 0, y is 1. When x is -1/4, y is -1/2. Well, the so what is, because I did this candidates test and I listed out the values that would give me the absolute maxes or mins, the biggest y is the absolute max. So the absolute max is 17, and it occurs at x equals 4. Sometimes you're also asked where it occurs, but the max is 17, it's the y value. And what's the absolute min? -3. It's the smallest of these values.
Students and teachers, please pardon this interruption. Today, we will be conducting our bus evacuation drill on Bulldog Boulevard. When your area is called, please exit Bulldog lobby and board an available bus. Please leave all belongings in the classroom during the drill. At this time, all classes on the 3rd floor, please report to Bulldog lobby for the bus evacuation drill.
Okay.
All backpacks and belongings should be left in the classroom.
I'll shut the door behind us so your stuff will be safe in here, but let's hustle there and then hustle back. I think it's so funny that they do the bus thing so late in the year. It's like, if you're going to ride the bus, you probably already have, and like if you needed to know that stuff, you should have already been shown it.
I also find it funny people like, we're not gonna jump out of the bus, we're gonna sit down and scoot out. It's like, if there's a fire, I'm jumping out of the bus.
Yeah, but if everyone just rushes out, then people are gonna get hurt. But if the person behind you rushes out and knocks you down, and then people start stomping on you, and then you're stuck there burning.
Students and teachers, please pardon this interruption. At this time, all classes on the second floor should report to the Bulldog lobby for bus evacuation drill. Again, all backpacks and belongings should be left in the classroom.
Okay, I'm gonna wait just a couple more seconds. I don't want to add to y'all's plate, so let's go ahead and return to what we were doing. So, I know we had gotten the answers to this question, but I needed to emphasize a couple things to you. And honestly, this is about the end of the notes for extreme value theorem and candidates test. Like, I pretty much said all the stuff you needed to hear before we got interrupted. But the parts I need to emphasize is notice that critical numbers were not just helpful for figuring out when something's increasing or decreasing. They weren't just helpful for finding relative extrema, but they also help us find absolute extrema. So this idea of critical numbers, we're going to be doing and using and talking about critical numbers most of the rest of the days in this semester. So sooner you memorize critical numbers, or when the first derivative is 0 or undefined, then the better that will go. The other thing I need to emphasize is that not if, but when you see this on an FRQ, because they always put this on your AP exam, so I'd say there's a 99% chance it would be on your test as well. Maybe not this unit test, I don't remember, but at some point in this year we'll have one. What you need to know is that this candidates test, this table right here, is what's considered showing your work. This is considered the justification. Justification. So, like a lot of FRQ stuff, sometimes getting the final answer is tough, especially if it's one of those parts that's hard to interpret what they're wanting you to do. But if it's absolute, max, or min, like it probably would have just been one of these questions. And so sure, you'd get 1 point for getting the answer right. But sometimes they give a point, well, it's always tied behind justification, but sometimes they'll give a point showing that you tested the endpoints, and another point if you showed that you tested the critical numbers, which you're supposed to be doing anyway. So sometimes this right here could be 3 points of an FRQ. So basically all we have to tell ourselves is that if we want absolute max or min, test the endpoints, test the critical numbers, compare the Y values, the biggest ones the absolute max, the smallest ones the smallest min. So okay, and then there's one more kind of, I don't know if this question's super fair at this point in the year. It's kind of weird that they're bringing this up, but I want you to put some thought behind question 2. Notice that this is the derivative, which changes things, and they're trying to get you to think about what x value is there an absolute max and what x value is there an absolute min, just knowing the derivative. So I want you to think about that for a couple moments to see what you think you should do, and then we'll make sure we're all on the same page there. So before I tell you the answers, let me give you a hint that sometimes it's kind of nice to sketch what you think the function might look like. So I've got a point. I have no idea what the starting point is. They don't tell me in the directions. They certainly don't tell me by this graph, because this is not f of x, this is f prime of x. So I'm just going to pick a point. Does my graph go up, down, or constant? What does it do at first? And how do you know it's going up?
Positive f prime.
Okay.
Positive derivative.
Exactly. When the derivative is positive, which if it's a derivative graph, positive stuff is above the x-axis. This kind of shows how quickly and for how long the graph's going up. So it's going up for a bit. When the first derivative is negative, notice I'm not saying anything new, it's just the information's presented in a different way. When the first derivative is negative, the graph is going down. Now, do you think it's going to go down more than it went up? Now, this looks like it was going up for longer, and this is going down for a shorter period. So, I don't know. It goes down some, but not down more than this. And then we go back to first derivative being positive, but just for a second. So it's kind of like that. Okay, well, where was the absolute max then? X equals 1, because it was at some point, and then when the first derivative is positive, it's going up, 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 up for a long time. Then it goes down, 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 up, up. So its absolute max would be 1. I think if I'd asked you guys what you thought, most of you might have gotten that one right, but I think this one's going to be a lot more missed. You're going to think about, okay, it goes up a while, but then it goes down, 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 down. So why is x equals 3 not the minimum?
Didn't go like all the way down below where it started.
Right, so again, it kind of helps if you try to sketch this. You guys told me that this was going up a lot more than this was going down. So notice my f of x graph down here. If I try to estimate how much it's going up, going down, and going up, so I can give myself a visual, it's pretty clear that the absolute min would be at the -3. The other way that you could talk about this is because it's not really how long or how much, it's a combination of the two. So it's really that we're comparing the area under this curve, because this kind of shows how much change there is, how long and for how much. Compared to this area is more than that area. That's how we know it's going up, more than it's going down. And this idea of finding area under a curve like this with all this curvature is actually something that we do in calculus. So it'll be like January probably before we get to it, but with really like just a couple more calculus things under your belt, you would be able to find the area of a shape like this that has curvature, that doesn't fit a nice neat geometry formula. So we'll talk about area under a curve quite a bit second semester, but for today, this is a way to kind of pull all that stuff together. Okay, so now we need to go in possibly one of two different directions here. So again, just because your class was a little bit disjointed on 41 between, it was a weird day to give you the notes to that, and then I had you finish it after the test, but some of you took longer on the test, and so some of you got more of it done in class than others. And all of that's important. This is the foundational stuff that we're starting with for Unit 4 that we're going to be building upon. So if you struggled with something from Assignment 41, or you could never figure out how to make it work out for you in Assignment 41, I want to help you with that and make sure that we're all on the same page there. If you're good with that, go ahead and stay on this 42. Just go ahead and start practicing the practice questions after the notes. But otherwise, I will help with 41. So, number 4. Right here? Okay. So, check in with me real quick here. Make sure that on assignment 41 from last week, if number 4 was a tough one for you, pay attention to me for a few minutes. If you were good with this one, just work a question or two on assignment 42 while you wait. Okay, so this question, or on this assignment, we were only worried about relative maxes and mins. So relative maxes and mins have to occur at critical numbers. It doesn't mean that critical numbers have to be relative maxes and mins. You need to understand how it's one way and not necessarily the other way. So, critical numbers, the definition you have to know as soon as possible is when the first derivative is 0 or undefined. Please keep saying to yourself 0 or undefined. This is one of those things where 95% of the time you just work with it when it's 0, but then on the test it'll have stuff where it's undefined. So you got to know both. So sometimes you've got to take the derivative, but this one the derivative's already done for you. So I know that this is never undefined because there's no x's in the denominator. To get undefined, you have to try to divide by 0. So there's got to be some value of x that gives you division by 0. But I could set it equal to 0, the other thing in critical numbers, and I can set factors equal to 0. So where x plus 4 equals 0 and where e to the x equals 0 would be my critical numbers. So of course this one is pretty quick. Just subtract 4 from both sides. This one takes a little bit more thought. And now you can do this a couple different ways. You could just guess and check. You could think about what numbers could I plug in for x to make this be negative, and you're never going to think of one. Because e's a number. If you give him a positive exponent, it's a positive number. If you give him a 0 exponent, anything to the 0 power is 1. And even if you give him a negative exponent, it's just like moving him to the denominator, which is still positive. This guy is always positive. Another way is if you know what exponential growth graphs look like, you could see that, well, it's never negative, but it's also never 0. I probably have a graph like that over there. Maybe not.
You have the graph.
Oh, wait, exponential, right here. Right there. In fact, here is the exact same one, e to the x. So e to the x, 5 to the x, 3 to the x, they all basically look like this. It never equals 0. Or the algebraic way to figure that out would be like, you could take the log of both sides, which is okay to do as long as you do it to both sides. And oops, here you could bring the x down but this is a problem. This is not possible. You can't take the log of 0, you can't take the log of a negative number. For the same reason, there's no number that makes e to the x 0, because there's no exponent on 10 that gives you 0. So this just never happens. So there's only one critical number, and again, critical number means it is likely, but not guaranteed, to be changing directions there. So I start my little number line chart thing, and we always have to test around all the critical numbers. So the fact that this only has 1 is kind of nice because there's less stuff to test. If I know the direction to the right and to the left, then I know the full direction, because critical numbers are the only place the graph might be changing directions. So test anything to the right of -4. I'm going to pick 0 just because 0 is easy. And make sure you plug it into the derivative. I don't care what his value is at 0, I care what his slope is at 0. So I would get a 1 times 4, which is positive. When the first derivative is positive, the slope is positive, so the graph's going up. And plug in something to the left of -4, like, I don't know, -5. And you'd get a negative times a positive, which is negative. And when the derivative is negative, that means the slope is negative. And when the slope is negative, the graph's going down. So all of that to see, find the relative max and mins. Well, now I can see there's a relative min here. It was going down and it starts going back up. So my answer is relative min at x equals -4. And the reason why is because the derivative switches from being negative to positive there. There's my answer and my justification. Okay, was that enough for 4? Okay. Does anybody else need to ask about 4 have something more detailed than what I covered? Okay, what else could I help with from last week's 41? I know the last question looks pretty scary, but it wasn't too bad once you actually did it. But is that it for 41? Well, I'm glad you guys didn't have a ton of questions, because that meant that you did put in a good effort into it, like I always ask you to do. And then I will ask for that on Wednesday, since I wanted to give you a chance to ask about it today. So there's no point in turning it in today. So the 2 other things I want you to try to get done here is I'd like you to try to finish up 42. So the notes that we started class with on extreme value theorem, candidates test, absolute max and mins, all boils down to basically make a candidates test, which is a table where you check the critical numbers and the endpoints. Biggest y value there is the absolute max, smallest y value there is the absolute min. And make sure you're making a habit out of making that table. That's called the candidates test because that's your justification. And I think that's about all you really need to know for this one. The math here is not, there's really not a ton to know about it. You just have to practice it a few times to get the hang of the process. So let me give you a few minutes to get going here, and then I will offer to help out with 42. So if you get hard stuck on a question, just put a star by it and then be ready to ask about it when I interrupt you.
Students and teachers, please pardon this interruption. At this time, all classes on the first floor should report to the Bulldog lobby for the bus evacuation drill. Again, all backpacks and belongings should be left in the classroom. Thank you.
Let me offer help with the first couple, if anybody needs it. So, you guys can check your answers with the class website, but if you haven't started doing that yet, here are my answers to questions 1 and 2. Absolute min and max was 1 and 37, and then 0 and 9 for those two. Okay. Would it benefit anybody for me to show you how I got those answers on those two? Either one of those two. Okay. Go ahead, keep going then, and I will do the same. I shared my answers with 3 and 4 on the board. So I would be happy to work out either one of these two or both of them if you need it. So while you guys check that and decide if you want me to work one of those out for you, again, you may not appreciate this, but I think this is really beneficial to you guys. I'm looking ahead, forcing you to, like question 3s, forcing you to do quotient rule, you know, which may be not your favorite type of derivative, but if you don't practice doing it occasionally, then you forget the pattern. I haven't worked question 5 yet this year, but I can look ahead and see that's product rule. So they do sprinkle in some good derivative practice in here too. Number 4, taking the derivative sign, stuff like that. But does anybody want me to go over number 3 and or number 4?
You can do 4.
Number 4? Okay. And actually, I'm kind of glad you asked about 4 because I felt like when I was at the end of this question, I felt like I should have known these answers should have kind of made sense. Like if you think about the unit circle. So okay, give me 1 sec. Forgot to do something here. Okay, so question 4 is asking us to find the absolute max and the absolute min, which is really, they're asking us to apply the extreme value theorem, which again, you don't have to know the name extreme value theorem, but what extreme value theorem tells you is that the absolute max and absolute min will occur at either the end points, which are going to be given to you in the question, or at the critical numbers, which we need to be experts at anyway for other question types. We've looked at already in just a couple classes, talked about critical numbers a few different ways, and there's going to be a few more ways we use critical numbers also. So critical numbers are when the first derivative is 0 or undefined. So the derivative of sine something is cosine something. You should think about chain rule, but in this case, the derivative of the inside is just 1, so we didn't have to do chain rule here. Now, trying to figure out where this equals 0 might be the hardest part of this question. So what I did is I thought about the unit circle, and sine or cosine is 0 when x is 0. So at pi over 2 and 3 pi over 2. But that doesn't mean I want x to be pi over 2 and 3 pi over 2. I want x plus pi over 4 to give me pi over 2 and x plus pi over 4 to give me 3 pi over 2. So that I'm taking the cosine of an angle that actually gives me 0. So I just made an equation. What could I add to pi over 4 to make it be pi over 2? That's pi over 4. And what could I add to pi over 4? What plus pi over 4 would give me 3 pi over 2? Because the cosine of 3 pi over 2 is 0. So subtract the pi over 4 over, you get 5 pi over 4. Yeah, because this is like 6 pi over 4, so subtract 1 is 5 pi over 4. Yep. Are you okay with those critical numbers? Okay. So now again, by the way, you don't have to say, hey, I'm testing critical numbers and endpoints. You're never going to lose points if you don't write that. I just think it's a good habit because it forces you every time to remember, these are the things I'm supposed to check. This is what extreme value theorem tells me to check. Now, be careful not to plug these numbers into the derivative. The derivative's going to tell you the direction of the graph. I don't want that. I want to know the values. I'm trying to find the max value, the min value. So plug in these x values into the function. The sine of pi over 4 is square root of 2 over 2, which as a decimal is about 0.7. If I plug in 7 pi over 4 and add 1 pi over 4, that's like 8 pi over 4, which reduces to 2 pi. The sine of 2 pi is 0. If I plug in pi over 4, add pi over 4 is pi over 2. The sign at pi over 2 is 1. And then when I plug in 5 pi over 4, add 1 pi over 4, that's like 6 pi over 4, which reduces to 3 pi over 2. And the sign at 3 pi over 2 is negative 1. Now the real work is done. The biggest number over here is your absolute max, and the smallest number over here is your absolute min. Now, before I started this question, I told you I felt kind of silly at the end and realized, wait, I really should have known this. This should make sense with what I know about the unit circle. Unless we really restricted these angles, just think about the unit circle. Sine starts off as 0, it gets as big as 1, it gets as small as negative 1. So unless you really restrict these angles, sine is going to be as much as 1 and as low as negative 1, which is what we discovered here. So starting off at 0, but then I add pi over 4 to it, I was really starting here. So from here to here, the biggest sine value is 1 and the smallest sine value is negative 1. So I feel like you could have maybe answered that if you're really good and really comfortable with unit circle. But at the end of the day, you need to make sure, maybe the most important thing today is this idea of the candidates test that I'm highlighting. This is what they consider showing your work for these questions. Even if somehow you could do that in your head and you didn't have to put pencil to paper to say what the answers were, the highlighted part is the showing your work part, showing that you understood which ones could possibly be max and mins, and to test those. Which ones are actually candidates and what are not candidates. So you wouldn't lose points if you tested other x values. You probably would lose points if you don't test all 4 of those x values though. So always test the endpoints and always test the critical numbers. And then your max and min has to be in that list. Okay, anything more specific than that? Okay, did anybody change their mind about number 3? Okay, then actually I might as well leave this up. I'm going to keep working and you do the same, please. Okay, my answers to 5 and 6 have been up there for a little bit. Anybody like me to go over number 5, ward number 6? Oh, I'm sorry, I didn't even share it. 5 was e squared and negative 1 over 2e, and number 6 was 13 and negative 7. No takers for those two? Okay. How about questions 7, 8, or 9? Try to zoom where you can see my answers if you didn't pull them up yet. I actually missed one part of number 8. I just didn't do it very carefully. But any of those 3 you would like to discuss? Yes.
Can you do 9?
Number 9? Sure. Okay, so notice 9 says no calculator, so you need to make sure that we're not just graphing with the calculator and looking at the answer. That's not the practice that you need. Get that out of the way. Okay. So our function is cosine squared minus cosine, and we are interested between 0 and 3 pi over 2. Find the max value and the min value. So I know that's extreme value theorem, which tells me to test the endpoints, which they gave to me, 0 to 3 pi over 2. And any of the critical numbers, which they didn't give to me, so I have to go and seek those out. So critical numbers are when the first derivative is 0 or undefined. Now, I anticipate that for a lot of you guys that missed this one, is probably this part of the derivative. And we talked about this quite a bit in Unit 2, but it's not something we practice on a regular basis. Cosine squared, when we square and cube and raise trig functions to an exponent, we like to write it like this. It's just a notation that we use. But what it really means is you've got cosine squared. So the first part of this derivative is power rule. Bring the power down, lower the power by 1, and then there's a chain rule step. The derivative of the inside is negative sine. The alternative, to me, I think this is always preferable. Power rule is just so easy. But if you were not sure how to deal with that, you could change cosine squared into cosine times cosine, do the product rule, and you would see that you got that same piece there. So I'm expecting that that's probably a lot of the mistakes was that part. Then the derivative of cosine is negative sine, so that changes that to a plus. And if I'm trying to find critical numbers, I want to know where this is 0 or undefined. Now, sine and cosine are never undefined, so it's really just where does this equal 0. And you could factor out a GCF of sine. And then some of your critical numbers will be where sine is 0, like 0 and pi. And then some of them will be where cosine is a half, which is pi over 3 and 5 pi over 3. But I did not include 5 pi over 3 because that's not between 0 and 3 pi over 2. It's not in the restricted domain that they want me to work with. So there was 3 critical numbers, 2 endpoints, and then I started plugging those into the function. You plug 0 in up here, you get 1 minus 1. Plug in 3 pi over 2, you get 0 minus 0. You plug in, oh, I don't need to do 0 twice. If I already plugged in 0 once, I don't need to plug it in twice. You're going to get the same value. So if I plug in pi, I got 1 minus negative 1. And when I plugged in pi over 3, I got a half squared, which is a fourth, minus a half. So a fourth minus a half is negative a fourth. Got to be extra careful with the arithmetic. So the absolute max was 2, because that's the biggest number sitting here, and the absolute min is negative 1/4. And I know I don't need to test any other x values because this is what extreme value theorem says. If you know which candidates to test, the endpoints and the critical numbers, then your absolute max and min are guaranteed to be sitting there waiting for you in the table. But again, the derivative of cosine squared, that's a very common thing. Make sure that you think of it as cosine squared with parentheses and start with power rule, or write it as cosine times cosine and do product rule. Whatever you think you're going to be more reliable on. Okay, Lucas had enough. Okay, anybody else going to ask about 9 while it's still up there? Okay, so I was hoping we'd be caught back up with everybody else, but that does not look to be quite the case. So let me tell you what kind of adjustments I need to make for you guys, and you might want to write this down since I'm not going to adjust the agenda here, because it's going to be fine for everybody else. But I gave you a chance to ask about 41 today, so I will definitely be taking that next class. I'm also going to take up 42. I won't take up 43 from you guys yet, but I would recommend that you maybe just do 2 or 3 of those questions. Again, there's really only 8 there. The last one has 4 parts to it, so I guess you could count it as 12 questions. So it's not going to be a long assignment, but do a little bit of it, and then I will give you another night of homework for it to actually have it done. But 41 and 42 absolutely need to be finished. Answers checked, make corrections, name on them, and ready to turn them in next time. 43, just make some progress on. I do need my book handouts back, so please don't tuck those away in your binder. Just throw them in the basket up front as you guys get dismissed.